Hey everybody, welcome to another con support video. This one's on scientific notation. Let's go. Let me zoom in here so you guys can see it a little clearer. All right, so let's express this number in standard form. So this is 3.643 times 10 to the negative 1. So that negative 1 exponent right there is telling you to move the decimal place 1 to the left. So this is going to be the same as 0.3643. Okay? Because what you want to do is you want to move the decimal one place to the left. So that negative 1 is telling you on the power of 10. Because what you're really doing here is you're timesing by 1 over 10, which is the same as dividing by 10. When you divide by 10, you move the decimal 1 to the left. All right. There's a shortcut to this negative 1 exponent. Another way to think about it is that you've got this 1 0 in front and then the decimal, right? So that's another way to look at it. All right. Let's just go to the next one. Here you've got 96,470,000, right? So if it says write this number in scientific notation, what you're going to want to do is you want the lead digit to be right between the 9 and the 6, okay? So that's where you want the lead digit to be, right there. I haven't really used this before, so it's not great, is it? Anyways, let's do this. I don't think this works much. No, it doesn't. All right, so anyways, so what you want is you want your lead digit to be, let me see if I can do this. Right. There we go. All right, so you want the lead digit to be between the 9 and the 6. So what you're going to do is you're going to move the decimal place that many places over. I think it's better if I just use this writing tool to copy it over. Let's do this. All right, that's better. So, hide that. Thank you. All right, so we got this one here. So 9, 6, and then comma 470, and then comma 0, 0, 0. So you want the decimal to be right here between the 9 and the 6 because you want the lead digit between the ones place. That's your goal, okay? So you're asking yourself, how far are you going to move this thing? You're going to move it 1, 2, 3, 4, 5, 6, 7 places. So this is going to be 9.6470 times 10 to the, and now this is a very large number, so it's going to be an exponent that's positive exponent because you're times it by a large power of 10, right, to make it back to its normally large number, right? So since this is a large number that is greater than 1, the power of 10 is going to be a positive exponent. So how many places did you move it? You moved 7 places, so it's going to be 10 to the 7th. 9.6470 times 10 to the 7th. So that's what you'd write over here. So over here on our paper, you're going to write 9.6470 and then times, and then 10 to the, and then push the A to B button, 7. Okay, this one's 31 billion. Well, you have to think about what the place value for billion would be, right? So this is 31 times whatever billion is. Now, we ask ourselves, what is billion, right? Well, a 1 with 6 zeros is million, right? So this would be 1,000 million. So billion is going to have 3 more zeros there, right? So this is going to be 1,000, million, and then billion. This is 1 billion. So what is that in terms of scientific notation in terms of power of 10? We got 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So what you're really looking at here is 31 times 10 to the 9th. But you don't want 31. You want the lead digit to be in the ones place, right? So you want the lead digit to be right there. So you want to have 3.1. Well, 3.1 times what? Well, you moved the decimal 1 to the left to get it into the right position, right? So you made the number look smaller than it is. So you have to expand this out 1 extra place to the right. So you're going to basically multiply not by a billion, but by 10 billion. So that's going to be times 10 billion, which is going to be 10 to the 10th. So this is the scientific notation in proper form. You want the lead digit in the ones place, and you want the appropriate power of 10 that's going to put the decimal where it belongs and show you the real value. So this is 31 billion because it's really 3.1 10 billion, which is the same as 31 billion. And so that's what you put here. So you're going to put 3.1 times dot, and then you're going to do 10 to the A to the B button, 10th. Okay, this next one says 2.0 Erase this stuff actually. Okay, this next one says 2.077 times 10 to the negative 4. Now there's a really easy shortcut for when you have power of 10 to the negative 4, signs of notation. All you gotta do is put 4 zeros, 1, 2, 3, 4, decimal after the first, and then the number. So it's 0.0002077. That's the quick way to do it. Just realize it's going to be 4 zeros in front with a decimal after the first. Okay? So that's the quickest way to do it. If you wanted to do it with a little less efficiency, then what you're going to do is you're going to ask yourself, all right, what is this really worth? We're going to take 2.077 and times by 10 to the fourth, which means we can move the decimal place 4 places to the left. Well, that means you're going to go past the 2, and then you're going to go 3 more places. See, past the 2, and then 3 more places. So it's really going to be the 3 placeholder zeros after the decimal, and then 2077, right? But you can put a 0 in the ones place as well. That's where the fourth 0 comes from. So anyways, either way, you're going to get the right answer, whether you move the decimal 4 to the left, or you think, oh, shortcut, 4 zeros in the front, decimal after the first. You're going to get the same answer. Okay? And so this one happens to be 0.0002077. All right. Let's do the next one. So this is a nice and easy one because they give us a number that's small, 0.0008235. We know that it's going to be something times the power of 10 that has a negative exponent because it's such a small number, less than 1. And all you got to do is recognize how many places are we talking about here with the zeros, right? So you got 4 zeros in front, the decimal after the first. Hence, this is going to be 8.235 times 10 to the negative fourth. That's the shortcut, right? To realize that whenever you have a small value, 10 to the negative whatever, it's just going to be the number of zeros in front, decimal after the first. Right? The other way to think about it is to move the decimal to the desired location, which is making the 8 in the ones place. So we're going to move it how many places? 1, 2, 3, 4. So you move it 4 places to the right. So that's why it ends up expanding back out outside the negative fourth, because what you're going to do is you're going to move it 4 places to the left to connect it back to its normal value. And that's how that works. So this is going to be 8.235 and then times 10 to the negative 4. Right? And this one's 78 million. So for 78 million, what you're going to do is you're going to say 78 times 10 to the 6th. Why 10 to the 6th? Because a 1 with 6 zeros is 1 million. All right? But you want the decimal to be between the 7 and 8. So what you're going to get is 7.8 times, since you move that decimal place 1 place to the left, you got to expand it back out. So you're going to change that 6 to a 7. So it's going to be times 10 to the 7. And what that's basically telling you is that 78 million is the same as 7.8 times 10 million. And so this is going to be 7.8 times 10 to the 7. So 7.8 times 10 to the 7. There you go. And then this one says express this number in standard form. You're going to basically move this decimal place 9 places to the right. So when you're doing this one here, it's going to be 3.868 times 10 to the 9th. You're going to move it 9 places to the right. And so you're going to go 1, 2, 3, and then past those 3, how many more places? 6 more places. So you need 6 placeholder zeros. So it's going to be 3, 8, 6, 8. And then you want to have 6 placeholder zeros. 1, 2, 3, 4, 5, 6. Because you're going to move it 9 places in all to the right. Okay? And so that's the answer you're going to have. So this is going to be 3, let's just write it out, 3, 8, 6, 8, and then 0, 0, 0, 0, 0, 0. That's the correct answer. Anyway, so that's how you do your scientific notation. Just make sure your lead digit is in the ones place. And that's how you do it. So let's stop that.